Good morning, everybody. Today we are going to see a chapter that is electric current through a conductor. Now, in this case, we are knowing that what is meant by current. So, when we say that with current, that time we are only aware about the word current, but when we try to define it, we find that the current is nothing but a flow of charge. Which charge? It is the charge called as electron. Now current is due to the positive charge also and negative charge also. Many times we find that the negative charge is studied oftenly. So, here the charge electron carries negative sign. So, hence, these electrons, they are present in the atom. Now, suppose for conduction, we take the copper material, and this is the good conductor of electricity. Now when we say that it is a good conductor of electricity, that time this atom, we say that it consists of nucleus which is positively charged, in which protons and neutrons are present, while the electrons are present in the shell or in the orbit around the nucleus. Hence, it follows the sp configuration. But in case of this copper atom in the last shell, there are few electrons which are not strongly bonded or binded to the nucleus, and hence by a small thermal energy, this get delocalized. These electrons get delocalized. When it get delocalized, they become free, and hence we call such electrons as the free electrons. Now these free electrons, they are able to move in all the directions. Now there are lack of atoms present in this material. So hence lack of free electrons becomes available to us, and these electrons move randomly. When they move randomly, that time we find that the net flow of the electric current is zero. How we say that it is zero? Few electrons move in the positive direction of x-axis, that much number of electrons also flow in the negative direction of the x-axis. Similarly, for y-axis and for z-axis, if we take their sum of these electrons, we find that the result comes out to be zero. When it comes out to be zero, this means that net flow of current is zero. So this is the condition when we say that current is said to be not flowing. But when we say that the current is flowing, then what is current? So according to the theory, we say that the flow of the electrons per unit time is called as the current. That is, I is equal to Q by T. What is Q? Q is the charge. What is T? T is nothing but the time in second. So, current is having the SI unit as charge is measured in terms of coulomb, time is measured in terms of second, and therefore coulomb per second is called as the ampere. Here the current is measured in terms of ampere. Now when we say that current is measured in terms of amperes, the value is very great. We can also measure that current in small quantity also. That is referred as microampere, milliampere, nanoampere. Now you know that micro means 10 raised to minus 6 ampere. Then we say that milliampere, it is 10 raised to minus 3 milliampere. So here, as we see that current is required for any devices, any gadgets to run, and hence we are much more commonly aware of this current. But theoretically, this current is nothing but we say that flow of charges, that is negative charge per unit time. Hence, I would say that current is the important factor. Next is that the flow of current which is taking place through the conductor, that is also important to us. During that time, the current which we are seeing regarding the wire, we call it. Now here we are going to take a copper wire, and that copper wire is also called as the conductor because it does the job of conduction of electron from one point to the another point. Okay. Now, in this figure, you will come to know that there is a plane, and in this plane, if you check out, you will find that we have given the notation Q plus and Q minus charges. Now these charges flows in the forward direction as shown in the figure. So here the forward direction is there, plus charges is also shown, minus charge is also shown, and these charges, when we say that the current is flowing, they are flowing in the forward direction. But when it is possible that external electric field is also applied, then what is the external electric field? External electric field is nothing but maybe battery, maybe eliminator, this cells which we use in torch, in remotes, remote control of TV, those cells, these are used for flow of current. Now these are connected externally. When they are connected externally, the electrons flows in the forward direction. When it flows in the forward direction, this means that the net magnetic moment will not be zero. The net electric field will not be zero. So this is how it functions. Now next is that when we are considering the current flowing through the conductor, that time we are considering that two conditions takes place: when the external battery is not applied and when the external battery is applied. When external battery is not applied, the electrons, that is free electrons of the material of copper or a conductor, it flows in random order. They are not supposed to be moving in a one direction because external electric field is not applied, and therefore that time we get net electric flow or electric field equal to zero. Now when I apply it, you will find that in the figure, this is the first figure where we show that random motion is taking place. In this random motion, you will find that the charges, they are free, but they move on their own will. They are not going to follow any principle. So hence, that time, we say that they are in a random motion. Now when we say that they are in the random motion, this is the first state without external electric field. But in case of application of external field by use of cell, you will come to know that the current is set up in the rod, copper rod, that is the conductor, and the electrons starts moving. When the electron starts moving, it is tending to drift in a particular direction. Drifting means it will it will move in the particular direction, and that direction is opposite to the direction of applied electric field. This means that, one example I will give you, that when the water which is coming out of the dam, when the doors are opened, they flow in one direction. But if a if a person who is swimming in the direction opposite to the direction of the flow of water, this means that his movement, his velocity is very small. It is against the direction of the flow of water, and therefore we say that the speed which is acquired by that person is said to be a drift one. Drift speed we call it. And hence, in case of this language of current, we say that the free electrons of the copper material, they are free, but they are traveling in the direction opposite to the external applied field. So here you will come to know that direction of the field and the direction of the drift velocity, they are opposite to each other. And hence, the net electric field or the net electric flow of charge will not be zero. Hence, we say that when the external battery is applied, we come to the conclusion that the flow of current is not zero. You will see some current, you will experience a shock when you touch to that current flowing through that conductor. If you touch that conductor or a copper wire, and when the current, the example is that in the household circuit, the current which is flowing through the copper wire, and if by some reason, if you touch that wire, you will get a shock. That means that that time the number of electrons which were flowing through that wire, because of us, because man is also, human being is also a good conductor, and therefore the area of cross section which we touch to that wire, the direction, some of the electrons turns in the direction of the human body, and as we are connected to the ground, the electrons flows through our body, and those electrons which are flowing through our body is very much large, tremendous in number, and therefore our body shakes. We feel the shock, and when that shock is experienced, immediately our body which is touched to that wire gets thrown in the outward direction. And then we come to the conclusion that no, Baba, there is a current inside this wire, and due to the mishandling of our person or a human being connecting directly to the conductor, a shock is experienced, and this shock is nothing but the flow of the current which has entered in our body. So, when we say that we are experiencing a shock, this means that now coming back to the point, that number of electrons, now we are taking the wire of copper or copper rod we are taking, that length is taken to be capital L, and therefore total number of electrons in that wire L is equal to NaL. N means number of electrons. A means area of cross section of that wire, and L is the length of the conductor. Hence, total charge. आता total charge काय म्हणतात Q. Q is equal to what? NaLe, because we have to multiply by the electron charge value, and therefore we get total charge is equal to NaLe. Now, we know the basic formula that velocity is nothing but displacement per unit time. But when I want to change the places of this formula, initially I said that V is equal to displacement upon time. Displacement will be how much? The length of the conductor which we have taken. Time is in terms of second. So now I want this formula in the form of second, that is T. So here T is equal to, capital A is called as the displacement. Displacement what? About the length of the conductor. And Vd is called as the drift speed. So when we see that, drift speed, it is found that the term Vd is used in this formula. So now we are having an equation T is equal to L upon Vd. Now this T is available. We know that current is equal to Q upon T. So now total Q value is there. So substitute that value NaVdE. Now, when we say that, we have got the value because substituting Q value T L by Vd, we get LL cancelled and remainder is NaVdE. Now again I want this equation in the form of velocity, drift velocity or drift speed. Then we change the positions of this equation and we get Vd is equal to I upon remainder, that is NaE. Now, current per unit area is called as current density. We know that. Density formula, basic. What is that formula? That formula is nothing but mass per unit volume. But in electronics, we call it as current per unit area. So we are substituting I upon A as J. J is known as the current density. Now, if I want the equation in the form of current density, the position will change to J is equal to Na multiplied by drift velocity. Now you see that this SI unit is ampere per meter square. So here all this today we have seen the basic things regarding the flow of current due to the charge. Charge are of two types, positive charge, negative charge, but mostly we have explained on the basis of electrons, negative charge. So today we will stop here.